Hello and welcome to the Oxford Mathematics Online Open Day in April 2024. It's fantastic to have you with us. Welcome to the day. My name's James Munro. I'm the Admissions and Outreach Coordinator. If we've met before, online or in person, then hello again. If we haven't met before, then hello for the first time. I'm here to talk about maths at Oxford and give you some details of the admissions process. And later in the day, we've got a Q&A section where I'll be joined by current tutors and students from Oxford Mathematics to answer your questions. It's great to have you with us from around the world, joining us for this Oxford Open Day. Currently in Oxford, it's a slightly overcast day. It's grey, it's the morning on a Saturday. I have a cup of tea though, so I think it's going to be okay. I imagine we've got people joining from around the world and around the UK, and I'm going to try and give information that's relevant to people wherever you're watching from. Mostly detailing what the maths course is like and how the admissions process works. Okay, I'm going to give it a moment for people to join in and explain that timetable of the day a little bit more. So we're at the top here. We're at 10 o'clock at the start with an overview. At 11 o'clock we'll do the full Q&A section where I'll be joined by colleagues and students. Later on in the day, to round out the experience, we've got some pre-recorded videos on particular maths topics. We like to put maths into our maths open day. So we've got some suggestions of other recorded videos that you might enjoy if you're looking for a bit of mathematics. There's a list of those and lots of other links to useful and interesting material over at the Open Days page. I've got the link on the screen here. The link is also in the YouTube description if you're watching on a separate device. It's probably the page that you were just on before you joined us on this YouTube stream. If you've somehow found us through the magic of the YouTube algorithm, then there is also an associated web page with information and links as part of the Maths Department's website over there. You can get involved throughout the live sessions this morning at slido.com/oxfordmaths. That's maths with an S. I'm afraid that's how we spell it over here. You can get involved in particular if you want to ask questions during the Q&A session, but also if you want to join in during this live session this morning. It's not appearing on screen, but I do have the Slido open if you want to say hello, tell us where you're watching from, or already start asking questions. The plan is that the overview is packed with information that I get asked about during a normal Q&A session. So I'm hoping that during that first session we answer some of the questions before you've even asked them. But I'm sure we'll have plenty to talk about when the tutors and students get here at 11. Okay. YouTube tells me that people are still joining, so if you've just joined in the last couple of minutes, hello, this is the Oxford Mathematics Online Open Day. My name's James Munro. I'm the Admissions and Outreach Coordinator, and I am going to start by telling you about Maths at Oxford and the admissions process before we're joined a little bit later on this morning by tutors and students for a Q&A session. Right, okay, I think if it's all right with everyone, I think I'll get going with my overview material at the top. My plan is to deliver this as in the same style that we would at the Open Day in person. So for the in-person Open Day that we held last week, we held that in our Maths Department, which is called the Andrew Wiles building. It's named after mathematician Andrew Wiles, who has an office here as a mathematician in Oxford. Andrew Wiles, famous for proving Fermat's last theorem, which you can find out more about on other websites, I'm sure. But we're very pleased with the Andrew Wiles building as well as being pleased with Andrew Wiles. The building is 10 years old now. It's a nice modern building filled with lecture rooms for us to teach mathematics in, smaller classrooms for us to teach smaller optional courses or to hold graduate classes or seminars for working mathematicians. It's the home of teaching mathematics in Oxford. This is where the lectures for all of the maths courses happen throughout all of the years of the maths course, but it's also the home of maths research. The building has these offices upstairs which are filled with graduate students and researchers and other people doing cutting edge mathematics. It's nice having everyone in the same place throughout the course, so that as well as having the lectures here, the people who are lecturing also have their research space here. The building's equipped with a cafe and some study areas and space for people to meet each other. I've started with the Andrew Wiles building to show you the kind of sleek, modern maths facility, because I think this might not be what people imagine when they first hear Oxford. Perhaps you're imagining dreaming spires and Hogwarts, Harry Potter, and all sort of stone masonry, and Oxford has all of that. Of course we do. Lots of places you can get a look at the Oxford scenery. In the background of that left photo, you can just see the Radcliffe Observatory, which is a historic observatory on the site. Oxford has all of that ancient history, of course, but we also have modern teaching facilities, and the mathematics course in particular I think is good for being up to date and accessible and useful for employers and all that sort of thing. So in some sense, two sides to Oxford, our historic side and also our modern cutting edge facilities. Okay, nothing wrong with a little bit of Hogwarts though, I always say. In fact, this seems like a good moment to mention the role that colleges play in Oxford. Oxford's a little bit different from most universities in that, as well as being a member of the university, students here are each members of a college. There are 29 colleges with maths students, and those students belong to that college. It's where they live, at least in first year. They get student accommodation arranged via their college, and the colleges have a canteen and social events, clubs and societies. The colleges are a really important part of being an Oxford student, a sort of community within a community. So students in the college study a full variety of subjects, and there might be just 6 or 7 maths students within that college. Of course, all of the maths students have their lectures together, same maths lectures for everybody, same mathematics at the end of the day, but the college then provides that kind of smaller group of just 6 or 7 of those students living in the same college in first year. The colleges also organise some small group teaching, so as well as the lectures, Oxford gives quite a lot of support, and a lot of that support is organised by the colleges. So they're important in giving us an almost individual look at how students are doing with the course to keep people up to speed. We think that college teaching is really important. But I'm getting ahead of myself. I should tell you about what courses we've got and what the structure of those courses is. Okay, Andrew Wiles building here. So Oxford courses, we have quite a few degree outcomes that people graduate with. I know this table has maybe more rows than you would expect perhaps. The important message for people thinking of applying to the course is that most of this you don't need to decide when you apply. For example, the courses on the board here appear in 3 and 4 year variants. People can graduate after 4 years with a master's qualification, or graduate after 3 years with what, for historical reasons, is a Bachelor of Arts, but it's a bachelor's degree from the mathematics course. People can graduate after 3 years or 4 years, and you don't need to decide which one you're thinking of doing at the point that you apply for the course. People generally decide along the way whether they want to stay for that 4th year master's qualification or not. There are joint honours courses on the board here. We have mathematics at the top, but then 3 joint honours courses: maths and statistics, maths and philosophy, and maths and computer science. The way those first 2 work for maths and statistics is, again, we don't make you choose before you apply. Students on those courses do exactly the same things in the first year and decide midway through their second year whether they're on the maths course, studying maths options, or whether they're on the maths and stats course. And the maths and stats course has access to more modern statistics courses, data science and machine learning, but has some required courses in order to unlock those options. So people make that decision along the way. In fact, the only decision you need to make if you're choosing between these when you're applying is whether you want to apply for that maths and stats course, or maths and philosophy, or maths and computer science. Those joint honours courses combine together about half of the maths material with, on the one hand, philosophy content. If you're interested in the intersection there of logic and proof and what it means to know something for sure, what it means to have a a proof that could be checked by a machine. If you're interested in that kind of intersection of logic and truth and understanding, then the maths and philosophy course might be interesting to you. We do ask you to choose between that one and the maths course, because you're asking to do philosophy study right from the start. And similarly with maths and computer science, about half of the maths content is exactly the same as the maths course, and the other half of the content is supplied by the computer science department. So if you're interested in the fundamentals of computer science, the underlying algorithms and the design principles behind algorithms that help people to make efficient software that eventually gets implemented somewhere, if you're interested in that fundamental, several layers deep, then the maths and computer science course is a really interesting way to get some experience of working at that level. It's not a course in the kind of particulars of game design or applications of computer science to robotics or some specific application. It's working on some abstract level. And those joint honours courses are a little bit smaller in terms of intake than the large mathematics course at the top of the board, but I'm really interested in all of them when it comes to looking at prospective students. Okay, so lots of lines on the slide, but in terms of applying, you'll make a choice between maths, stats, if you're interested in that, or maths and philosophy, or maths and computer science, with choices throughout the course of how to proceed. Okay, those are the courses that we're offering. Let me talk a little bit about what's in the maths course. What would you study if you studied maths at Oxford? When the first year, there's compulsory core courses, things that we think every mathematician should study. I've got a list of topics on the board here. Some of them I imagine you've heard of before, so integration perhaps, and some of them maybe you haven't heard of before, so perhaps Fourier series is something that you haven't met before. If you're taking A-level, there's no Fourier series in there. So we like to take some topics that people haven't seen before, that they will need to understand modern mathematics, and some topics that people have, but we can teach them again from first principles, to teach them with mathematical rigour and to show people why things work. So even if you've seen a little bit of group theory before you get to university, seeing group theory again from first principles, alongside people who are meeting it for the first time, we think that's the right way to go for everyone to have a kind of common first year. So depending on where you're studying before university, you might have met different topics, you might know more or less about different things in the first year. I know that some people arrive having already seen quite a bit of real analysis, and some people arrive with quite a lot of experience of kind of the calculus BC, of the kind of doing lots of calculus and integration. But we teach both of those topics for the audience as a whole, without assuming that people have seen specific content before. We think this gives people a solid foundation for the later years, which I also want to show you. So later on we have the option to specialise. There we go, later years. Gosh, that text has got rather close to me. Later on we have options in the second year to continue study in those areas, as well as specialising and applying it to particular areas. So I've got some examples of applications on the board: mathematical biology, quantum theory, machine learning and network theory later on. Options to take that mathematical power that you get from understanding those core courses to specialise a bit more and to apply it to something in particular, if people are interested in that. From the midpoint of second year, the maths course is entirely built out of optional courses. The way the third year currently works is there's a list of optional courses and people choose what they want to study from that list. There's a bullet point on the slide about potential careers, and I think the thing I want to say is that maths graduates are in high demand by employers. If you've studied a mathematics degree, then you've demonstrated that you're good at learning complicated material, you're good at applying it, you're good at solving problems, you can definitely work with data and numbers, and there's lots of employers who are interested in people with those transferable skills. A lot of our graduates go on to work in areas such as finance and software, but the pie chart breaks down really quickly after that. So there's lots of people going to consultancy and teaching, and then lots and lots of other interesting areas as well, using a bit of what they've learned from the maths course and a lot of their transferable skills. There's a really good careers service at the University of Oxford that tries to help our students to work out what they might want to do after Oxford. And it's a service for life, so people can get in touch after they've graduated from Oxford to get a bit of career support and help as well. Okay, that's kind of very big overview of what's in the maths course, some core content on things maybe you've heard of and things maybe you haven't heard of, so that we can try to get you up to date with modern mathematics in a variety of areas of perhaps your choice as we go through the course. I want to talk a little bit more about how we teach then during the course. So there's a photo of a lecture room on the right. That's our largest lecture room in the Andrew Wiles building, Oxford. A typical week in first year at least would be 10 lectures, Monday to Friday, perhaps 2 every morning, Monday to Friday. In the Mathematical Institute, we also at the moment record our lectures and put them on the web for students to watch back. The lecturers set a problem sheet at some frequency, depending on the course, and that problem sheet provides a kind of framework of how students might be following the course. They might need to reread their notes from the course, they might need to do some independent study to think about the material and to try and understand it, and then to take the problem sheet and try and solve some related questions. The problem sheets are supposed to be difficult. The lectures contain a lot of content, and we can do that because we've got strong students. We've got people who we know will put in the time to do some independent study, and also because we have the support in the first 2 years of college tutorials. That's the small group teaching that the colleges organise with 2 or 3 students, 1 tutor meeting to talk about the problem sheet. So at the moment I'm a tutor at New College, and I'm seeing my first year students on Mondays. We get together, I see them in pairs, and sometimes they've done all of the questions, they've had a wonderful time, and we talk about where the course is going. We talk about what they might do next with this understanding, maybe try some harder questions. And sometimes they come and they've thought about the questions, and there's something that they don't quite understand, or maybe something they think they don't quite understand, that we can talk about in the tutorial. And it's a way to support the students to make sure that they're keeping up with quite an intense workload to learn quite a lot of mathematics. I suppose I've mentioned workload and quite a lot of mathematics there. I hope that sounds like a good thing to people watching this open day. If you'd like a maths course with lots of maths in it, then I think Oxford Mathematics is the sort of course that you're looking for. And maybe you're the sort of student we're looking for too. So self-study is important. There's libraries across Oxford and study spaces, and working with other students as well I think is important. Colleges are really good for that, to have that kind of smaller community where within your college there might be a smaller number of math students who are nearby. We think it takes about 40 hours a week. There's no count of how many hours my students are spending thinking about mathematics. I think my students managed to find a healthy balance between work and leisure to think about the maths problems, but also take part in other opportunities around the university. There's a lot of extracurricular things going on in sport and music. Some of my students have been involved in the theatre before, both front of stage and behind the scenes. There's a lot of opportunities across Oxford, and I hope when we get to the tutor and student panel, I hope you get a chance to ask the students about what they're getting up to as well as their mathematics. Okay, that's kind of a typical week in first year. As we go on through the years, those tutorials that I've mentioned eventually get replaced in third and fourth year by intercollegiate classes. That's as the options get more specialised and we have fewer students doing those options. We organise a system of getting people from different colleges together for a larger intercollegiate class to talk about their problem sheets. But the spirit is still very much all the way through the course that people see the maths content, think about it a lot, try some questions, and have some sort of meeting to discuss their work and what's going on in the course. This flexible approach is really helpful to us, especially for an international student cohort where we have people from different backgrounds and different educational systems. This means that we can help people no matter what particular mathematics they've seen before. Part of our aim is to teach things from first principles and to teach things without making assumptions about what people precisely have studied before. As we do that, the tutorials and then the classes are a really key component of that. Okay, so let's talk a little bit about exams, just to finish up this first section. There's a photo on the right there of some students, I think, getting ready for an exam, about to go in. Historical and traditional reasons, students in Oxford dress smartly for their end of year exams. And in the first year we assessed through 5 of those 2.5-hour exams at the end of first year. Along the way, students have a small amount of coursework. They have these computational projects where we teach students a little bit about getting computers to help with maths problems, and they have a small amount of coursework to have a go at that. Later on, it's still mainly exams throughout the maths course, but there is a dissertation in the 4th year, and the option earlier on to do some project work, maybe a presentation, other forms of assessment in small parts. Okay, I'm going to pause briefly here, partly to drink tea and partly to judge my timings. Okay, I think I'm doing all right. I haven't told you about admissions yet, of how, if you want to study maths at Oxford, how that process might work. And I think I want to spend the time here talking about admissions. Quick think about the course structure then as an overview. I hope I've convinced you so far that our maths course is full of maths. We have students who want to see lots of maths content, who want that challenge of being shown maths that they've never heard of, maths that they've wouldn't perhaps otherwise learn. They want that challenge of having something difficult, to not water it down, to do the maths. We've got students who will really put in the time as well to try to understand that and to get the most out of those small group tutorials, to ask questions and to learn from the people giving the tutorials. We're looking then for people who are inquisitive and good at learning mathematics and good at solving maths problems. I give that as an overview before I start talking about the nitty-gritty of how the admissions process works in practice, because that's our guiding idea throughout, that we want the people with the most potential to succeed on our maths course. It is an academically demanding course. Okay, right, feels slightly odd to do that all over the slide on assessment, but it's not all about exams, but there we go. Okay, so admissions, let's talk about that. To explain why we have an admissions process first, it would obviously be much easier if we didn't have quite so many applicants. We're in this lucky position as Oxford that lots of strong maths students would like to study with us. They perhaps see our maths course and think, yes, I'd like to study maths at Oxford. So we're really grateful to have at the moment a lot of really strong applicants like yourself. We have a limited number of places on the course. It's limited for a couple of reasons, partly due to lecture space here in the Andrew Wiles building, partly due to the number of spaces in the colleges. The colleges are committed to providing a certain amount of accommodation for students, so that rather than renting privately, students can have accommodation in college, at least for 1 or 2 years of their degree. Those effects limit the number of places on our course to approximately 200 mathematicians of some variety each year. We want the students with the most potential to succeed. So we want the people who are going to get the most out of the maths degree. Broadly speaking, I've got some numbers on the board where I've used PPP to stand for people per place. So the final people per place is the number 1, because we end up with 1 person per place on the course. At the moment, for the maths course, we have about 10 times as many people applying as we have places, so about 10 people per place. And I've put some numbers on there to show you through the process how we get down from 10 people per place to that on-course population. We do some amount of processing to shortlist for interviews. So not everybody gets invited to interview. We're focusing our interview resource on those people who we think will get the most out of those people who we think we stand a chance of making an offer to. We use the interviews together with all the information that we had before to decide who we're going to make our offers to. At Oxford, we're not in the business of making dramatically more offers than we have places. We make about 10% maybe more offers than we have places. By and large, when we make an offer to someone to study on the course, they almost always take up the offer, meet all the requirements, and start the course later that year. So we make very nearly the same number of offers as we have places on the course. That means that we have to do our shortlisting before that stage. Before we get to the offers, we have to narrow down the numbers. So I want to talk a little bit about the steps along the way in chronological order to guide you through what would happen if you made an application to Oxford. The dates in this section refer to 2025 entry. If you're applying later this year, 24, if you're applying later this year in 2024 for admission to start the course in 2025, these are the dates. If you're watching this video in the future, or if you're interested in applying in a future year, then please check the websites for updated course details, including any application deadlines or details of when things are happening. Okay, so let's go step by step. There's a UCAS application at the start. UCAS is a web portal that almost all UK universities use to handle applications. This is sort of basic information about who the applicants are. So we need a UCAS application so that we've got a record of who you are and that you're interested in applying to Oxford. We use what UCAS call the early deadline. For us, it's the deadline, which is Tuesday the 15th of October this year. That's applications for entry in 2025. So almost a full year before the start of the course, we're taking applications in UCAS. As part of that, you provide information about yourself and your previous qualifications, if you've completed some qualifications, as well as details of qualifications that you haven't completed yet. It's normal for people to apply before they've finished school or pre-university study. That's because we're asking for applications almost a full year before the start of the course. It's normal for people to have a plan during that year to complete their A-levels or AP grades or whatever they're doing at the moment. So perfectly normal to put the application in before you've completed school leaving qualifications. There's a section on the UCAS application for you to declare such qualifications not yet completed. And that's perfectly normal. We have the ability later on, if we would like you on the course, we have the ability to make that conditional on you staying in school if you're in school, or at least completing your qualifications and getting particular grades. Later on in the process, I'm going to talk about conditional offers, and that means an offer to start the course with conditions that you complete particular qualifications. And you've seen the numbers, so you know that almost always when we make someone a conditional offer like that, they go on to meet the conditions that start the course. And perhaps motivated by having the offer from Oxford, people tend to make the grades that we've asked them to get. Anyway, I'm on the UCAS application still, because there's a section of the UCAS application where you write a personal statement. You're asked to talk about how you're preparing for university. If you're doing something outside the classroom to help you get ready for maths at university, I don't know, perhaps you're reading around the subject, perhaps you're looking at other sorts of activities that you could do to get an idea of what maths is like. In general, people write these personal statements to give us some context around their application, and they're very interesting to us. We do read the personal statements, we do look at the personal statements, we take them seriously. They have information in that often for some applicants we can only get through the personal statement. So if there's some important context around your application that you want us to know, so if there's something in your, educational history that doesn't fit in any of the boxes, the personal statement is really useful to us as a way for you to tell us something that we should know. So as you're making your application, you have this freedom to write in the personal statement section about your application. For Oxford Mathematics, we use the personal statement and the rest of the UCAS application as one source of information. It's not the case that we necessarily deselect a large number of people based on their UCAS application. In general, almost all of our applicants have very strong UCAS applications where they list qualifications that have gone reasonably well, they list qualifications they're going to take, and their personal statement tells us that they like mathematics as well. So in general, most people's UCAS applications are not the distinguishing feature between applications. I'm saying this because I think people worry quite a lot about the details of how they phrase their personal statement or what precisely they should or shouldn't mention, whereas in practice we just don't have that kind of checklist of things that you must say. We don't have a blacklist of things you must not say. We just want to find out about you and your application. Okay, as part of your application you name a UCAS referee. That's somebody who knows you academically, so maybe a teacher or a tutor. The rule is that it's not someone you're related to or a friend. It's someone who can comment on your academic progress. They will be asked to predict a grade for anything that you haven't yet completed. So if you have some qualifications not yet completed, because it's a full year before you're starting university, then your referee will be asked to make a guess as to what's going to happen when you take the exams for that qualification. Okay, so this information is all very useful to us. It gives us some context around your application, but it's not very mathematical. And we want the people with the most maths ability to succeed on our course, the people who are going to do really well at those tutorials and problem sheets, the people who are very keen to learn lots of mathematics and solve lots of problems. So before interviews, we have another step, which is called the Maths Admissions Test, which is, as the name would suggest, an admissions test. We use it for admissions, based around mathematics. And this is an Oxford test. It's set up by the University of Oxford. Questions are written by people in the maths and computer science departments at Oxford, and it's tailor-made for us to use to help us shortlist people for interview. So it's not the only thing that we use for shortlisting, because of course we have all of this information from UCAS and other factors, but we have this maths admissions test as a way to give everyone who's applying a chance to solve some tricky maths problems. The idea is that the test is difficult but not impossible, that the questions are hard but based on a relatively limited list of maths topics, because again we've got people from around the world, we've got people who are learning in different systems, so we've limited the maths that we're using to a really narrow syllabus of topics, from which we have to write difficult questions. The questions have to be difficult because it's people like you taking them, so we have to write these hard questions that use a limited syllabus of mathematics. Okay, I'm going to show you one of the questions and explain why I don't have more information about the maths admissions test on this slide. So here's a question at the bottom which involves logarithms, and that the base on that logarithm is the polynomial x squared plus 2, which I don't think I've ever seen outside of this MAT question. MAT, sorry, short for Maths Admissions Test, MAT, MAT. So I think this is a good example of a sort of question here where if you know some laws of logarithms and if you know some facts about polynomials, then perhaps you can start to unpick what's happened in this question and start to make progress, even though well, you've probably never seen logarithm with base a polynomial before, and I don't think you need to have seen it before in order to get through the question. Oh, I suppose you do need to have seen logarithms. So if you haven't learnt logarithms yet, then I think great news. You're going to learn logarithms quite soon, I imagine, and I think you'll enjoy them. So on this slide, I would normally give you the date of the test and the format of the test. But because it is currently April at time of recording, and because this year the university is reviewing arrangements for all of the tests, not just the maths test, we have several in different subjects. Because it's April and there's a review going on, at time of recording, at time of live broadcast, we don't have an announcement on the date of the test or the precise format of the test in terms of the length of time, the number of questions, where you'll take it, what the format of that experience will be like. I'm sorry for the delay there, but I want to reassure you that the syllabus, the content of the test is not changing. Past questions are still good practice. We have a large bank of previous maths submissions tests, and we're going to write questions on the same topics in the same sort of style, combining together ideas or setting unfamiliar questions based on those ideas. So the correct thing to do now, if you want to prepare for the maths submissions test, is perhaps to look at that syllabus, to look at this list of topics that I keep mentioning. It's one side of paper to tell you what topics there are on the mat. And then perhaps to look at some past questions, which I want to reassure you are still good practice for the maths submissions test this year. There's a website on screen here, which is the maths page. I hope it's also what comes up if you search for mathematics submissions test. And that page will have updates on format and dates and registration and how it will work for the actual admin of the test. But because you're very keen and watching an open day in April, months ahead of the date of the test, I don't have those details on the slide yet. Sorry again. I wonder if people at home are trying to solve my maths question. I'll have a quick look to see if anybody wants to talk about that. So the question, if you've been trying to solve it along the way, I think a good first step is to try and get rid of the logarithm. So if you do something to get rid of the logarithm, then hopefully this will turn into a kind of polynomial question. From there we can try and use polynomial skills. And for me at least, the pattern there is unfamiliar question, I don't know what I'm doing, I'm willing to try something, I'm willing to try undoing that logarithm. What would it be? Something like x squared plus 2 to the power of both sides or something. I'm willing to consider taking that step without being able to see what the next step is. So I'm willing to sort of take one step and see where we're going. Sorry, excuse me. An anonymous person has joined the Slido chat to tell me the answer. Yes, thank you, brilliant. This is good news, and thank you also for showing me that the Slido is working. So if you want to see the answer to this question, you can join slido.com/oxfordmaths with an S to get involved. And they've posted a description in there as well of how the question works. Okay. So maths submissions test. We use that as shortlisting. We don't have a hard pass-fail mark for the mat. We look at the score to see whether we want to shortlist that candidate or not. And there's a team of hundreds of people involved in reviewing applications to look at the information that we've got and the mat score to decide whether or not we want to shortlist people. Aya in chat says about learning logarithms, and I want to reassure people that the content on the mat is based on what we think is in the first half of A-level mathematics. So if you're learning A-level mathematics over the course of 2 years, then depending on where you are in that, there might be some of the first half still to go. this is starting to sound like a question about fractions. There might be some content that you will learn between now and the test, which is approximately October or November later in this year. After the UCAS deadline, we're going chronological, but before the interviews in December. Yes, okay, good. Right, I'm slightly distracted now by talking about the logarithms as well, which is usually what happens when I put a maths question on the board. Let's talk about interviews then. So we shortlist people based on the information available to us, and we invite some students to interview. The interviews are online and they're mathematical if we're shortlisting for mathematics. The candidates applying for maths and philosophy can expect to have interviews on mathematics and probably separate interviews on philosophy, talking about concepts from philosophy. Candidates from maths and computer science can probably expect separate interviews on maths and computer science. But I want to focus on mathematics just to reassure all the mathematicians watching that maths interviews for maths candidates involve maths questions. We don't need to ask questions about your background because we have the UCAS application. We have, by this point, seen your maths submissions test and marked that. This is our chance to ask you some more maths questions. I've got an example of a maths question that I've used before on the board. I'm not going to use this one again. The idea is I have a parabola, y equals x squared. I have two fixed points, A and C, and I want to put the point B somewhere on the parabola in between A and C to make the area of the triangle ABC really large. And really large. And this is a good question, I think, for getting people started because there's lots of different approaches that you might use. During an interview, the candidate will try to do a maths question usually, and the interviewers are there to take notes and to watch what's happening, but also to help, to join in, to give prompts and to help guide the student, like I would with one of my students in a tutorial or one of my students who's trying a tricky exam question or something. I'd like to try and help them to get them towards the answer. I know how to do this question. I'm not going to tell you, but I'd like to see if we can work it out together. So, and if we can do that question, then I've got another one, and if we can do that one, maybe we're running out of time, but maybe I've got another twist on the question. Interviewers are looking for students who have some fluency with maths techniques, of course, but also the ability to generate ideas, to adapt ideas, to take something they know and maybe apply it in an unfamiliar way. Perhaps an interview might quickly teach something new, something pretty simple, or at least straightforward, or at least something you can explain quickly. Might teach something new and then see if the students can do something with it to work with that information. I've got suggestions on my quadratic in chat as well. Good, okay. So these are maths interviews for maths applicants, which we're going to use to help us make our final decisions about who we're making offers to, which we take very seriously because we know that almost all of those people are going to start the course and be our students. So we make our offers very carefully, looking really closely at borderline candidates to make sure that we're taking overall the candidates with the best chance of success at Oxford. This feels like a good moment to mention colleges again. So on your UCAS application, you can name one college if you have a preference of the Oxford colleges. If you do, then that's the first college that will consider you, but other colleges will have the ability to see your application, and at the interview stage, other colleges can even make you an offer if the first college doesn't want to or doesn't have space. Other colleges can get involved at that stage as well to arrange more interviews or to just make you an offer or to give you a place on the course. That's important because we want to take the best students overall. Even if all of you apply to the same college, even if you all put the same preference down, we still want to take the best students. So we have some mechanisms for shuffling people around a little bit between the colleges when we need to. There's also an option on the UCAS form to make what's called an open application. If you do that, then you're expressing no preference between the colleges and one will be assigned to you. So almost straight away, certainly before anybody's reviewed your application, a computer algorithm assigns you a college and you are then treated exactly as if you applied to that college. The tutors won't even know that you made an open application. So by the point of interviews, you'll be indistinguishable from other candidates who named that as their preference of college, not a selection criterion. So it's not an advantage or a disadvantage to make an open application. That option is just there if you want to make an application with no preference. Yeah, some questions about making an isosceles triangle, which I like as a question because I can talk about it. On a Mac question, the question is just there in black and white. On the interview, we can talk about it. If you want to make an isosceles triangle, I can ask you why. We can try and do the maths to make an isosceles triangle, and we can ask what it is about triangles that makes them large. Is it having the sides the same length? I suppose maybe you were thinking equilateral triangle, but realised that maybe an equilateral triangle wouldn't fit. And we can talk about whether you want to sacrifice side length for a little bit more area, and maybe we'll get towards some sort of understanding of what it is that makes a triangle large, which I think you know several ways of making triangles large. I'm being vague to try and set you up to say something clever, which is something I'm often doing in interviews, trying to set people up to say something clever. Yes, okay, good. Okay, so after interviews, we look back at all the information we've got and we use that to make offers. I've got some standard conditional offers on the board coming up now. I want to stress that this is the sort of standard starting point. If you're studying A-levels, for example, if you're studying A-levels, you've applied for maths and stats, and you're doing maths and further maths A-levels, we would usually make you an offer that said A star in maths, A star in further maths, A in any third subject. For maths and computer science, there's more text on the screen there. The standard is slightly more complicated. I want to stress that we have lots of these for other international qualifications. There's a link on the Open Days website for you to find out more about other standard conditional offers that we make, and that this is the standard, but we can adapt this to other situations. For example, if you're doing 4 A-levels, then the standard would usually be A star in maths, A star in further maths, A in either of your other 2 A-level courses. So if you're doing maths, further maths, French and Spanish, then it would be unusual for us to choose between French and Spanish and just say, look, you need to get an A in a third subject. We don't have a requirement for physics. We don't have a sort of admissions advantage for physics. We would just like people to be doing as much maths as they can in general. Okay, people are still telling me about parabolas. There we go. Okay, I've got an IB offer on the board. We would normally look for people to score 39 with 766 at higher level, including 7 in higher level mathematics. We'll accept either of the 2 pathways that are available there, and we have some standards on advanced hires as well. But I think I will let people look up other international qualifications on the website. The general is that we're looking for high standards across the board, reasonable workload, and top grades in mathematics. The offer there doesn't involve previous qualifications, so we don't have any requirements for your GCSEs. We don't have any requirements for things that you've done before. It's about those school leaving qualifications for us. If you've got GCSEs, we will look at your GCSEs as one bit of data on what happens when you do lots of exams, but we're more interested in these more recent qualifications that you're taking. Question in chat already about EPQ. EPQ doesn't form part of our standard conditional offers. If you're doing an EPQ, which is an extended project qualification, you get to write an essay, which might be a fun experience, and it might be something that you could base parts of your personal statements on. It's probably a good experience, but doesn't form part of our standard conditional offers. Okay, a couple of quick words about support from Oxford. I want to highlight a couple of things that Oxford is doing to try and help applicants. One of them is, oh no, here they are. One of them is the Mat live stream, which is on this YouTube channel. If you follow this YouTube channel, you'll see in June that we're doing a series of live videos to help people with maths problems and revising the maths on the syllabus. At the moment, if you follow us, you'll see that on Thursdays we're actually doing a different project called the Oxford Online Maths Club, where we talk about fun and interesting maths problems. The main channel, second channel, Oxford Mathematics Plus, the main channel has some student lectures. I've linked to a couple of them on the Open Days page. Later on, you might be interested in looking at some of our lecture notes. Have a look out for other events as well. Yes, people are talking about making a tangent parallel to a line, and it's all looking pretty good. Okay. Quick plug here for the Oxford Online Maths Club, where we talk about maths problems. This might be a chance for you to find out about some maths that isn't taught at school in your particular setting. Although I don't think the sum of two squares is taught in anybody's school setting. Correct me if I'm wrong, but mostly we're trying to show you people content that they haven't seen before. Maybe you'll discover your new favourite sort of mathematics through there. Gosh, it's slightly strange having being in the square and then down there is another square with me in. All of my live stream setups look about the same. Speaking of that, there's the Matt live stream advert again with a link which is on the Open Day page as well, and if you're following this channel you can't miss it. And we're going to switch to a Q&A. So we're going to take a quick break. Back at 11, people are telling me about the sum of two squares now. You can take it. We'll take a quick break to set up the student and tutor Q&A. We'll be back at 11 o'clock on this YouTube channel. So for me, it's the same place. For people watching, I think you need to change to a different link from the Open Days page. But similar idea, we're going to broadcast on this YouTube channel to answer your questions. Before that, you're welcome to get involved to post questions in the Slido. I'm going to tidy up the Slido a little bit so that questions can come in. You have a couple of options there. If you get to slido.com/oxfordmaths, link on the Open Days page. If you get to the page, you can post a question that you'd like us to look at, or you can give thumbs ups to other people's questions to help them rise through the set of questions in there. So I'm going to take a quick break to set up the tutor and student panel. This might be a good chance to stretch your legs, get a glass of water or a cup of tea, and I'll see you again in about 8 minutes for a Q&A session on this channel. Thanks for watching the first part of the online Open Day. See you again in a moment.